Imagine, if you will, a computer so powerful, it makes your fastest laptop look like an abacus. Can you? Welcome to the world of quantum computers. Now, we're not just talking about a step up from your everyday tech. No, we're venturing into a realm where the rules of reality as we know them get a little bendy. Quantum computers have the potential to outshine our classical computers in ways we can hardly fathom. They owe this mind-boggling power to some intriguing quantum properties. Ever heard of superposition or entanglement? These aren't just fancy buzzwords, they're the secret ingredients that could make quantum computers the next big thing in computing. But don't worry, we're not going to get lost in the technical jargon, we're here to explore the big picture. So, you're probably wondering, what do these quantum computers really do? Buckle up, we're about to dive in, and don't forget to subscribe for more enlightening explorations into the world of quantum computing. Let's start with the basics. What sets a quantum computer apart from your everyday computer? Now imagine you're at a party. A classical computer is like that one friend who always sticks to their routine. They'll always have the same drink, always stand in the same corner, always leave at the same time. It's predictable, reliable, but not particularly flexible. That's because classical computers operate on bits, a series of zeros and ones off or on, just like our friend's rigid party routine. Now the quantum computer, on the other hand, is the life of the party. It's like that friend who's up for anything, always surprising you, always changing it up. This is because quantum computers operate using qubits, which, unlike bits, can be both 0 and 1 at the same time, thanks to a nifty quantum trick called superposition. Try to picture a spinning coin mid-air, not just heads or tails, but both at once. That's our superposition. And here comes the real party trick: entanglement. Imagine you have two spinning coins, one in New York and one in London. Now as soon as one of them lands, say heads up, the other one, no matter how far away, will also land heads up. This instantaneous link, defying the limits of space and time, is entanglement, the quantum version of synchronized swimming, if you will. So, while our classical friend is still sipping their usual drink, our quantum friend is doing a synchronized dance with someone on the other side of the world while balancing a spinning coin on their nose. It's a whole different game, isn't it? Quantum computers, in essence, exploit these quantum phenomena to process information in a way that's fundamentally different from classical computers. It's like comparing a bicycle to a rocket. They'll both get you moving, but one of them can take you to the stars. Now that we have some understanding of how quantum computers operate, what tasks are they really good at? That's what we're going to delve into in this part of our quantum exploration. So, let's start with complex simulations. Picture this. In classical computing, simulating a molecule becomes exponentially harder as you add more atoms. This is due to the fact that each additional atom interacts with all existing atoms, increasing the complexity of the simulation. But quantum computers, with their superposition and entanglement abilities, are designed to handle such simulations with relative ease. They can process all possible outcomes simultaneously, making them ideal for simulating complex systems like chemical reactions or weather patterns. Next up, optimization problems. These are problems where you're trying to find the best solution among a vast number of possibilities. Think of it like navigating a maze, where you're trying to find the quickest route to the exit. Classical computers would have to check every possible path one by one, which could take an eternity. But a quantum computer? It can explore all paths at once, dramatically cutting down on the time needed to find the best solution. Finally, let's talk about factoring large numbers, a cornerstone of modern cryptography. Classical computers struggle with this task, especially as the numbers get larger. But quantum computers handle this task with aplomb, thanks to an algorithm known as Shor's algorithm, which can factor large numbers exponentially faster than any known algorithm on a classical computer. These are just a few examples of the tasks that quantum computers are specifically designed to tackle. These tasks are currently difficult, if not impossible, for classical computers to perform efficiently. It's like asking a horse to win a race against a rocket. The horse is reliable and has served us well, but the rocket is simply in a different league. In short, quantum computers excel at tasks that require exploring a vast number of possibilities simultaneously. So, we've learned what quantum computers do, but what does this mean for us? Well, the potential impact of quantum computing is massive, and it promises to revolutionize numerous fields. Let's take medicine, for instance. Quantum computers could help us discover new drugs and analyze complex medical data. They might even enable us to understand our DNA better, leading to advancements in personalized medicine. Imagine a world where your doctor prescribes treatments based on your unique genetic makeup. Fascinating, isn't it? Then, there's finance. The financial industry thrives on data and predictions. Quantum computers, with their superior processing power, could handle vast amounts of data in a snap. They could optimize trading strategies, manage risk better, and predict market trends more accurately. The financial world could become more efficient, and perhaps, a bit more predictable. Artificial intelligence is another area where quantum computing could make a significant impact. By processing complex algorithms faster, quantum computers could give AI a boost. They could help AI learn and adapt quicker, making it more intelligent and versatile. The possibilities are mind-boggling. But it's not all rosy. Quantum computing also brings challenges. One of the significant threats is to our current encryption methods. Most encryption today relies on the difficulty of factoring large numbers, a task quantum computers could handle easily. This could leave many of our current security systems vulnerable. But on the flip side, quantum computing could also pave the way for new, more secure encryption methods. It's a double-edged sword. As with any technological advancement, there will be pros and cons. The key lies in understanding the potential and the pitfalls, and preparing for them. As we continue to explore the quantum realm, who knows what other surprises we may find. Quantum computers are not just a new type of computer, they're a whole new way of thinking about what computing can do.